Hello and welcome to another Docker tutorial. Today we're going to be looking at volumes and persistent storage in Docker containers. First and foremost, let's take a look at the problem which we run into when we first set up any sort of container. For that, first and foremost, we're going to have to go and set up some sort of container in our system. Let's set up a core system with some sort of Linux distribution. I'm running an Ubuntu on my core system, so we're going to try some different operating system. Let's try Debian. Going to Docker Hub, we go to Debian in the search bar, and here we have Debian operating system. Let's take a look. I want to use a smaller version of the operating system, so I'm going to use the Debian 10.4 Slim version. Let's go into our terminal. Let me just double check the instructions here. Docker pull Debian. We can pull the image first, or we can run it right away, and when we simply start running it, it'll pull it anyhow. So in the first tutorial, I believe we did a pull. In this tutorial, we're just going to run it. So let's check the tutorials for Docker run quickly. We did a quick introduction to help in the last tutorial, and right now we're going to take a look. Okay, so we have Docker run options and then the image. We're just going to do Docker run and then image and then colon tag. The tag is going to be the distribution, which is 10.4 Slim. Let's get this done. Colon 10.4 Slim. Let's run this thing. Okay, so as we can see, when I first ran it, it could not find an image locally on my system, so it decided to pull it from the Docker Hub, and that's what it did. Let's take a look at our current images. So here we have a Debian Slim and then our Jenkins from before. Let's take a look at what containers are running. Now, while it did pull the Debian Slim down, the container shuts down right away as soon as it starts. So over here it says exited 46 seconds ago. Essentially this means that the Docker started, ran, and exited. The thing about Docker containers is that there has to be a definition of some sort of command that is going to keep running a service throughout the entire life of the container. If the container signals that it stopped running service, it will exit and stop working to free up the operating system resources. So in order to keep this container running so that we can go into it and do something with it, we need to define some sort of command. Let's take a look at the Docker run command once again. Over here we have run, options, image, and then the command. This command is a very important setting. If you do not have a command set, the container will most likely exit unless it is configured with some sort of command to run by default. This operating system container is what's called a core container or a root container. They are basically the type of containers that you start to build out your main image, which would run things like databases or a server or something like that. They are not configured to run any sort of service command after they finish starting up, so they will just exit. Therefore, we need to configure some sort of command to prevent it from doing so. So once again, we'll run container docker ps. There's nothing. Right now, if I run Debian Slim in the same way as I did before, there will be nothing again. It will just exit immediately. There's nothing here, and let me see if there's a -a here. Yes, there is. So over here, it exited. It tried to start up another container, but it basically exited right away. And now let's add an extra command here. So now that we set the definition of this, we can add a command to run for the container to run once it starts up. So since we want to keep this container running, we'll do tail-f dev-null. What this will do is it'll essentially prevent the container from receiving an exit code. It'll just connect it to the dev-null device, and the container will just keep on running until we exit it manually. Let's see what happens now. The container has started. Although we did start it in the we did not start in the detached mode, therefore let me just try and restart it again. My terminal got sort of stuck now because I did not start in the detached mode. Now that it's sending everything to dev null, the container just keeps on running. Here we are. I closed off the other container because I cannot control it simply due to this dev null command, which is running at the tail end that's container setup. But the container is running and it's just going to keep on running indefinitely. We can now log into the container using the exec command. What we have to do is docker exec. Let's just check a help for this thing. So the exec command is used to log into the container from our command line. We can do it using an interactive mode and also need a tty, sudo tty. Well, we basically need this. So docker exec -ti. Then we need to define the container that we need to log into. The name of this container is kind pair. This is the name, the default name. Let's try this out. And then we need to define what we want to run inside this container. Most of the time you would want to log into bin bash, into a born again shell, although some containers, like for example Alpine, will not have it available. So you will need to log into regular shell with just using sh. In our case, we will try to log in using bin bash. And here we are logged in as root into this device right here, born again shell. If you list something, we're inside this operating system, the Debian, and I can prove it to you by running cat etc/os release, and it says it's the Debian distribution. Now let's try and create some sort of file somewhere around here. Let's cd into home. We don't have anything here, but what we're going to do is we're going to try to create some sort of file. By default, the nano, which is the text editor, the command line text editor, is not found inside this installation. Let's just install nano anyway. Now that we're logged in as root by default, we don't have to worry about running sudo. And most of the containers don't have sudo by default. Therefore, when you're creating a container image, sometimes you may need to change the user inside the Docker file, which is something we're going to be talking later on about how to create images on your own. In the meantime, we're going to install nano. I need to update. And now we need to install nano again. And we have nano installing, and it's now installed. So if I run nano, I'll just make some sort of test file and just run some sort of, write something here. This is a docker volume test to show that data does not persist after container shut off by default. Let's save this, close it, We have this test file now here, so if I run it, it is saved inside. This is our text. Now, let me log out of this thing, of the Docker container. So I'm exiting the Docker container. I'm back into my core host system. Let me run Docker PS. Our thing is still running. It's fine. Let me try and log back into it. Let me take a look if the file is still there. It's at the home directory. Our test file is still there. So if I do cat home test file, then it still has the content inside it. And we still have the nano. We can edit it if we want. And this is our editor, so we can still edit everything. It's working. Now, what we're going to do now is exit the container. And we're going to stop this container. So Docker stop. Let's take a look at the help. Well, I don't need to wait for anything, so I'm just going to stop the thing. So I just need the name or the container ID. The container ID is over here, the name is over here. I'm going to use the container ID this time. Our container is now stopped. Let me remove this container so that only the image is left in my system. By default, when you stop the containers do not get actually removed. They only get stopped. So before we start a new version of the container, you might consider removing the old version. Well, first we will start this container back up and see if our nano and our text file is still in it. Start the container. The container started back up, Docker PS. Here we are. Let's go and try log into it again. Use my exec command. Not whole home. Our file is still there, because we only stopped the container. We did not actually remove it. Let's try and stop and remove it next time. The container is stopped. Now let's list our containers. And let's actually remove it this time. Container is gone. Let's remove the rest of these Debian Slam containers, which we were trying out last time. Okay, those containers are all gone. Now, let's try and start up a new one. I need to run that Docker startup command once again. Not this one. Let me write it out all anew. Docker run Debian .4 slim tail f dev null, and this time I'm going to not forget to run it in a detached mode, so -d before the name of the container. Actually, -d before the name of the image, sorry. I'm also going to give it my own name. I'm going to call it my Debian. And the container has started. Docker ps. Here's my new container running with a different name, my Debian, the one that I specified here. Let's take a look if we have anything left inside of the container this time. Docker exec ti my deb. You can press tab if you just want to autocomplete the name. If it has unique name, it'll autocomplete it correctly. Now let's go into shell this time instead of bash. We went into bash last time. Let's try shell this time. This is what shell looks like. It's a bit different than bash. Let's list inside our home. Oops, home ls inside our home directory. So our file is gone. It's no longer there. Let's try nano. Nano not found. So as you can see, nothing is saved after we shut down the image and we remove the image. Nothing is saved inside it. Now, to deal with this problem, what we can use is volumes. Volumes can be used in a few different ways. There's generally two mainstream types of volumes. One is bind mount and the other one is an actual volume that gets stored somewhere inside the hard drive of your computer and is not accessible, at least not easily accessible from your host machine. We will be looking at all that in our next tutorial. For now, I just wanted to show you the type of problem that we can run into when we try to persist our containers in our system. Okay, I hope this was helpful. Thanks for watching. Like, comment, subscribe, and have yourself a good day. Bye-bye.